equation shows the crash severity function. Those who know the logistic regression model can understand those things. The y-axis says the severity, and beta represent the coefficients of the estimates, and x1, x2, and so on are independent variables. We have many variables in the crash database. We took all those take into account. And we know all those independent variables as well as the dependent variable. The challenge was to compute the coefficients estimate. We use the logistic model format to estimate in the coefficients. These are the model. I know you can't read those things, very small letters, but I want to show you in one slide. This is the model. In the first column you can say the variable labels, variable descriptions in the second column, and third columns the model we develop for the runoff road crashes, and the last column model developed for the non-runoff roadway crashes. In the runoff road crashes, we have two columns, one for the coefficients, the other one for the p-values. Coefficients we estimated through the logistic model, logistic analysis, and the p-values say as the significance of the variable. If it is less than 0.05, we consider as the significant variables. All the significant variables is noted with the star. Then we look at the coefficients and try to make conclusions. If the variable is significant, we can say that there is an effect due to that variable for the severity of the crash. And you can see there are some variables, the significant variables are marked with the star, and those significant variables, some are positive, some are negative. I will tell you how to interpret the coefficients. For example, in seat belt we have is a significant variable, and the coefficient is negative 0.7035. This means that if seat belt used, the severity is going to decrease. And on the other hand, if we consider the positive coefficients for the alcohol related, the coefficient is positive. That means if the crash is alcohol or drug related, then the severity is going to be increased. Likewise, we did the analysis for the runoff roadway crashes and non-runoff roadway crashes. There are coefficients with the significance with positive sign and negative sign, and not significant variable. On the other hand, non-runoff roadway crash model also have the significant variables and not significant variable. In the significant variable we have positive and negative. Now we identify the variables significant in both models. That means that those variables contribute to the increase the crash severity, whether it's a runoff roadway crashes or non-runoff road crashes. For example, alcohol involvement. Whatever the crash type, it is contributing to more for the severity. All those are expected results, but this one is a somewhat unexpected results. Holding a valid license, we expect the decreased severities, but this is somewhat through the model somewhat we got as interesting result. These are the variables significant in both models with negative coefficients. Existing of these factors is resulted decreased severities in the case of runoff roadway crashes and the non-runoff road crashes. This is very important slide regards to our study. These are the variables significant in the runoff roadway crashes, but not in the non-runoff roadway crashes. This means that these are the variables we need to consider if we need to decrease the severities in the runoff roadway crashes. And also there are some variables significant in the non-runoff roadway crashes, but but not in the run-off roadway crashes. If we need to decrease the severity in the non-run-off roadway crashes, we need to look at these variables. As a conclusions to this presentation, I would say that the logistic regression model is a good way to identify the differences between the run-off road crashes and the non-run-off road crashes. And we have seen that some factors are significantly associated with the run-off road crashes, but not in the non-run-off road crashes, and vice versa. This is a project is still progressing. Now we are in the process of making the recommendations to improve the roadside safety. We are looking at those variables to make the recommendations in the future. Thank you all for kind attention, and also in this point I would like to thank for the Kansas State Transportation Center and the Kansas Department of Transportation for facilitating this project.